Welcome. In this video, I'm going to show you how to evaluate this indefinite integral. First, we're going to identify which is our inner function and which is our outer function, since this is a composition of functions. And once we've done that, we can apply the substitution rule. So now recall, whenever you're doing an integral or evaluating an integral that's a composition of functions like this, so some outer function and some inner function, it's best to use the inner function as the substitution. In our case, our inner function is 2x minus 1, and the outer function is our square root function. And I'm going to leave this blank in here just to make it really clear. This is the outer and this is the inner. So we use our substitution as the inner function. So let's go ahead and say, let w equal 2x minus 1. This is often referred to as a u sub. Most videos you'll find, or information even in our textbook, will call it a u. But honestly, when we get to parts, there will be another u. And I don't want to mix these up, so I'm going to stick with w. Okay, so I'm going to start rewriting this as the integral of the square root. And now instead of writing 2x minus 1 here, remember, we're substituting this, so we're removing the 2x minus 1, and we're replacing that with the w. So let's go ahead and write that w here. And now we have to figure out how to replace dx. Well, to do that, let's rewrite this derivative. Let's evaluate this derivative of w. We're going to evaluate its derivative with respect to x. And remember, if you do something on one side, you have to do it to the other side. So dw is equal to, well, what's the derivative of 2x minus 1? It's just 2 dx. And let's ask ourselves, do we have an extra 2 floating around in the front here? We don't. So what I'm going to do is I want to get our dx all by itself here. That's what I want to do, as if this was an algebra course. So I can do that by dividing both sides by 2. And I end up with 1/2 dw equals dx. You can also write this as dw over 2. So look at this. If I want to replace that dx, since dx is equal to 1/2 dw, I can replace this dx with 1/2 dw. So let's do that right here. I'm going to write my 1/2 dw. Okay, so now my next step, I'm going to rewrite this. I'm going to bring this constant out to the front, and then I have the integral of w to the 1/2 dw, and this equals 1/2 times w to the 1/2 plus 1 over 1/2 plus 1 plus a constant. And all I've done is apply the power rule for integration, or that is, just found the antiderivative here of w to the 1/2 power. This is equal to 1/2 to the w to the 3/2 power divided by 3 over 2 plus c. So this is 1/2 times 2 over 3, w to the 3/2 plus c. And I'm starting to run out of space, so actually let's continue this up here. So this whole thing is equal to 1 over 3 w to the 3/2 plus c. And ask yourself, are we done? We are not done, because look, we started with x's and we're here with w's. We have to change our variable back to x's. So I'm going to write 1/3 parentheses and my 3/2 exponent here. And then I'm going to look up to my original substitution. I want to put whatever w equals back in here. So what did I say? W, we said earlier, equals 2x minus 1. So I know I can put this 2x minus 1 right here. All right, so what did we show? We showed that the integral of the square root of 2x minus 1 dx is equal to 2x minus 1 to the 3/2 power divided by 3 plus a constant. And there are many ways to rewrite this algebraically. 2x minus 1 times the square root of 2x minus 1 plus c over 3, or square root of 2x minus 1 cubed over 3 plus c. These are all equivalent. All right, keep calm and math on.